they have been question asked what's going to be the current through the emitters A1 and A2, right? So before getting into this question, let's hold it something like an equivalent resistance. If I just break this, you can see there is 3 and 6 along here. So it's going to be a 3 and 6 is going to be a 2 ohm resistor, right? And if you consider the resistance along here, 6 ohm, 6 ohm, 6 ohm, they are parallel. It's going to be another 2 ohm resistor. And along here also it's going to be 2 ohm. And you're going to have 18 volts. So if you consider the equivalent resistance going to be 6 ohm, so you would have a 3 ampere current flowing through this, right? So you would have a 3 ampere current which is going to flow through this. Now you can see there are equal resistors, which means there's going to be 6 volt in between him, 6 volt in between him, 6 volt. Now if you understand, the potential is going to be divided equally, such that the overall potential is going to be 18 volt. So in between this, it's going to be 6 volt potential drop. In between this section, it's going to be a 6 volt potential drop. And between this, it's going to be a 6 volt potential drop, right? So if I want a 6 volt potential drop along this 3 ohm resistor, there has to be a 2 ampere current passing through this. And if I really want, and if we really want a 6 volt potential difference through this, there has to be a 1 ampere which is going to pass through this. And this used to move through here. Now you can see there is 6 volt along him. So there has to be 1 ampere passing through this, 1 ampere along here, 1 ampere along here. So the 1 ampere which was passing through this moves in this direction. It doesn't move through this. So it's just going to move through here. The 2 ampere current which was passing through this used to break as 1 ampere and through here as 1 ampere. And finally, if you understand, there has to be a 2 ampere current passing through this 3 ohm resistor, and along him there has to be a 1 ampere current passing through him. So the current which was along here used to move in this downward direction, and this 1 ampere current used to get combined at a point so that there would be a 2 ampere current passing through this. So we are having the emitters A1 and A2 along here. So you can see along A1 there would be a 1 ampere current, and along A2 there would be no any current passage. Clear? So answers would be along A1 1 ampere and along A2 0 amperes. And it's really easy. An adiabatic process is given, right? So they want to ask you what's going to be constant with density. They have related with density. Now you know that in an adiabatic process we know PV to the power n is going to be a constant. Now if I really has been denoted with the density for a fixed, I'm going to divide by m to the power n, and I'm going to divide this side by m to the power n. Now the mass of the gas is going to be a constant, right? So due to that you would get P divided by density to the power n as another constant. So probably P times density to the power n minus 1. Sorry. So pressure times density to the power minus n is going to be a constant. So that's going to be our answer. So if you look at question number 18, they're asking us the potential difference between VA and VB. Now the information they have given us is there's going to be a 2 ampere current passing through here. So this 2 ampere current does not move anywhere. So the 2 ampere current does not get divided at any point. It's going to just move through here, right? So let's say up to here it's going to be 2 ampere anyways. And at this point the 2 ampere can break through or whatever. And they have also given us that the 3 ampere current is flowing through here and 1 ampere current is flowing through here. So obviously there has to be a 4 ampere current which is initially through this. So that 4 ampere current is supposed to be along here through. So this 4 ampere current divides to 3 ampere as well as 1 ampere, right? Now you know that there's actually 2 ampere current which was initially here. So how can it multiply to 4? So that there has to be a 2 ampere current passing through this. So that's going to be our idea. So if I obtain VA Now if I obtain the potential at here, 2 ampere current times 4 ohm, there has been an 8 volt drop along here. So VA minus 8 volt is supposed to be at this point. And obviously there is plus 3 volt along here. So in order to find the potential at D, you can see here there is almost another 4 volt drop along this resistor. There's a 4 volt drop along this resistor, and we are actually having a 3 volt. So at this 3 volt onto here and subtract by the 4 volt. So we would get VA minus 9 as the potential at D. And you can see that there's a 2 ampere current passing through this. So there's a 2 volt drop along here. So you should understand VA minus 9 is supposed to be equal to VB minus 2. So from here we can get that VA minus VB is supposed to be equal to 7 volt. Clear? So that's the answer for question number 18. So if you look at question number 19, they have given us some light sources, right? And using their wavelengths and the frequency, we can relate an expression for their frequencies. So this is going to be the order of their frequencies, where FB used to have the higher frequency, right? So FB used to have a higher frequency. Now you know that E is supposed to be equal to HF, where E is really depending on the frequency. If there was equal number of photons emitted by them, obviously the energy emitted by B would be greater than that of A, and that would be greater than that of C. But what they have said us is, they all used to have the same energy. They all used to emit the same energy, which means they have emitted different number of photons. So obviously, FC used to have the lower frequency. So he should emit more photons in order to achieve the high energy, right? And B has to emit less number of photons, so that obviously his frequency is greater, right? So that he is able to get that energy requirement, right? So it's going to be inversely proportional to the frequencies. So the photon order is going to be greater for C, and then for A, and then for B. So that's going to be the answer for question number 19. At question number 20, they have said us that the mass of this cube, including this ball, is going to be 1 kilogram. And they have said us by providing 300 kilojoule of energy, we are able to produce, that means we are able to melt this ice cube, this ice layer, right? So obviously, latent heat fusion, they have given us as 330 kilojoules, right? So if I apply m times of the latent heat fusion, we would get the energy required, which is 300 kilojoules. So from here we would get the mass as 300 divided by 330. If I divide by 3, I will be getting 11 divided by 10. So this would be the mass of the ice layer, right? But they are just questioning us what's the mass of this sphere. So probably we should subtract from 1 kilogram. We would get an answer around 1 divided by 11. Now this would be in kilograms. So if I convert it to grams, I have to multiply by 1000. So which is probably approximately around 91 grams. So that's going to be the answer for question number 20. Question number 21. A person of mass 50 kilogram is placed along here. Now this is going to be an accelerator, which means a staircase which used to move, so that it's capable of moving to a height of 10 meter. So if there was a person of mass 50 kilogram, he would be at here. So the work done would be mgh 50 times 10 times 10, which is 5 into 10 to the power 3 joules, right? But what they are saying here is, the person has been doing a work such that with respect to the person on earth, he is able to see that the person is at the same position. That means he is not moving on here. So what he has to do is, obviously he has to move down the staircase. So if he was somewhere around here, if he was starting to move downwards, so that he would remain in the same distance. But the energy which he has to do is going to be in minus. Make sure that you're going to be thorough with the sign, because work done by the lift or the accelerator is going to be positive, but work done by the man on the accelerator is going to be negative. Clear? So that has going to be minus 5 into 10 to the power 3 joules. And that's going to be for the question number 21. Question number 22. A planet is revolving around an orbit of radius r0. And they have said us that with time, the mass of the star used to reduce by 1%. So if I consider the initial mass as 100 m dash, after some time, the mass of the star would be 99 because it has reduced by 1. So it's going to be 99 m dash. Right? Now they're asking us what's going to be the new radius, orbital radius. So first of all, if I apply the gravitational force equation, it's going to be g times of 100 m dash, and let me say the mass of the planet as m. So 100 m dash times m is going to be equal to mv1 squared. Now v1 is going to be the orbiting velocity, v1 squared divided by r0, right? And they have said as it's a circle, so this velocity does not change, right? So after the next instance, let's say the orbital radius is r1. So if the orbital radius is r1, you're going to have g times of, now the mass of the star is going to be 99 m dash. So 99 m dash times the mass of the planet used to be the same. So it's going to be m divided by r1 squared. And obviously the orbital velocity would have changed, that as v2. So we would have mv2 squared divided by r1. So these are going to be our expression. So I'm going to obtain an expression between v1 and v2. So if I divide both this expression, I would get v1 over v2 whole thing squared, which is supposed to be equal to, now you can see r0 and this r0 used to cancel off, and r1 and r1 squared, this used to cancel off. So if I divide both this expression, I would get v1 over v2 whole thing squared. This r1 goes on top, so r1 divided by r0 times 100 divided by 99 as our answer, right? And what are the other equation you can get? Now you can see there's a change in the force, gravitational force, but the gravitational force is towards the center. Now when a force is applied towards the center, you know that there's no torque. So in both the situation, the torque which is applied is unchanged. So we are able to apply the law of conservation of angular momentum. If so, we can obtain another expression as mv times r. mv times r0, mv1 times r0, which is equal to mv2 times r1. So from here we would get that v1 divided by v2 as r1 divided by r0. Clear? And we have already obtained an expression for v1 and v2. So if I substitute onto here, I will get that r1 over r0 whole thing squared, which is equal to r1 divided by r0 times 100 divided by 99. So you can easily cancel off these answers. We would get r1 as 100 divided by 99. So r1 is supposed to be equal to around an answer like this. So that's going to be the answer for question number 22.